Hello. In this video, we're going to find the vertex and axis of symmetry of f of x equals negative 3x squared minus 2x plus 1 and put it in standard form. Then we're going to find the domain and range and any x and y intercepts. Now, to do this, the first thing we want to do is find the vertex, which means we need to find h. And remember, h is simply negative b divided by 2a. B in this problem is negative 2, so this is going to give us a positive 2 over 2 times a, which is negative 3. So this is just 2 divided by negative 6, which is negative 1/3. Then you plug it into the function to get the y value. So that's f of negative 3. And plugging it in, we get negative 3, negative 1/3, not negative 3. So this is negative 3 times negative 1/3 squared minus 2 times negative 1/3 plus 1. And then you can just type this into the calculator if you want, or you can do this in your head. Negative 1/3 squared is positive 1/9, because you just square both the numerator and denominator. So 1 squared is 1, 3 squared is 9. 1/9 times negative 3 gives us negative 1/3. Negative 2 times negative 1/3 is positive 2/3, and then plus 1. So now we have 1 plus 2/3 minus 1/3, but 2/3 minus 1/3 is just 1/3, plus 1 is 1 1/3, or 4/3. So that means that the vertex in this problem is negative 1/3 and positive 4/3. That also means that the axis of symmetry is, x equals negative 1/3. Because it's always x equals the x coordinate of the vertex. Fantastic. Okay, so the standard form from this is actually not too bad. It's f of x is equal to, now the a here is negative 3, so I do need to include this. So this is negative 3 times x minus the x coordinate, but it's negative 1/3, so that makes this plus 1/3. And then you square it. And then plus the k value, but that's positive 4/3, so we just write plus 4/3. Fantastic. Now, the domain, again, is all real numbers. The range, but notice that this one is actually opening down. So if we were to graph it, it's going to look something like this. Notice that the k value is the maximum value, and it starts at negative infinity. So we're going to start at negative infinity and go up to the k value, which is 4/3. Fantastic. Now we just need the x-intercepts and the y-intercept. We're going to look at the x-intercept first. First of all, notice that 0 is part of the range, so there will be x-intercepts. If 0 wasn't part of the range, just write none for the x-intercept. So I'm going to set the function equal to 0, so that gives me negative 3 times x plus 1/3 squared plus 4/3 equals 0. To solve this, I can subtract 4/3, so that gives me negative 3 times x plus 1/3 squared equals negative 4/3. And I need to get rid of the negative 3 out front. And normally you would divide by negative 3. Yes, I know what you were thinking. I'm psychic like that. Not really. But instead of dividing by negative 3, we can instead multiply by negative 1/3. So what that's going to do is give me x plus 1/3 squared is equal to Negative 4/3 times negative 1/3 is 4/9. Now I can use the square root property, which means x plus 1/3 is equal to plus or minus the square root of 4/9. But the square root of 4 is 2, and the square root of 9 is 3. So that means that I can subtract a third, which gives me x equals negative 1/3 plus or minus 2/3. So x is going to be two different values, negative 1/3 minus 2/3, which is negative 1, and negative 1/3 plus 2/3, which is a third. So those are the two x coordinates of the x-intercepts. So we have negative 1, 0, and we have 1/3, 0. It's always important to simplify this if you can. Sometimes you can't, often you can. Now notice that this is always going to be your x-coordinate of the vertex plus or minus some value. Okay. And then the y-intercept. The y-intercept is always 0, comma, a number. And that number, in this case, is right here. So that's going to give us 0, 1. Now, if you didn't like that, you could plug it into the standard form here, making that 0 plus a third is a third. A third squared is 1/9. 1/9 times negative 3 is negative a third. Negative a third plus 4/3 is 1. Fantastic. Just kind of separate this stuff here. Okay. Good deal. The last thing we need to do is graph. Now the axis of symmetry is negative a third. But here's the thing. I want to go ahead and graph this to where the vertex, or the x and y axis, well, the x and y axes are in thirds. So this would be 1/3, 2/3, 1, 1 1/3, 2 1/3, 2, and so on and so forth. And then on the y-axis, 1/3, 2/3, 1, 1/3, 2/3, 2, and so on and so forth. This just establishes the scale for the x and y axes. And the reason we want to do this is because the vertex here is all in thirds. So let's graph this. I'm going to graph this in a different color. Now the axis of symmetry is x equals negative a third. So a negative a third is actually going to be right here because we did our scale in thirds. So that's your axis of symmetry. Now, to graph the actual function. The actual function is, well, the vertex first. The negative 1/3, 4/3. So at negative 1/3, I need to go up 4/3, which on this scale is 4 tick marks. So that's the vertex. And notice that it's going down. Also notice that our y-intercept is 0, 1. So I have a point here, which means I also have a point here. And here the x-intercepts are also in terms of thirds, so that's negative 1 or negative 3/3, and then also 1/3. And notice that these 2 points are symmetric about the axis of symmetry. Fantastic. That's what you want. Now if you wanted another point here, I could also go right 3 and down 9 and go on from there. But notice that there's this negative 3 here. And most people would like to see this a little bit different. Or they might draw it a little bit different. If you did a different scale, it would look different. Okay, I'm gonna draw. I'm not gonna draw it. You can draw on your own paper what it looks like with a scale of 1. It's very hard to see this stuff right here. So because of that, that's the reason I did that 1/3 for my scale. Alrighty. Well, I will see you next time. Have fun.